A blessed day, classmates, and to you, Sir James, sir, our instructor. We are the group 7 and I am Daryl Atilano. So this group will be discussing about highway pavement materials and design. So we will know about what are the following materials and design that is used in making pavements in the highways. So starting with the introducing it, a highway pavement is composed of a system of overlaid strata of chosen processed materials that are positioned on the in situ soil, or which is termed as the subgrade. The pavement designer must develop the most economical combination of layers that will guarantee adequate dispersion of the incident wheel stresses so that each layer in the pavement does not become overstressed during the design life of the highway. So there are major variables in the design of highway, which are, we have here the thickness of each layer in the pavement, another the material contained within each layer of the pavement, and also the type of vehicles in the traffic stream, the volume of traffic predicted to use the highway over its design life, and also the strength of the underlying subgrade soil. So going more on it, we have here three basic components of the highway pavement. So one basic component of the highway pavement is, we consider the foundation. So the foundation consists of the native subgrade soil and the layer of graded stone, which is subbase and possibly capping, so which is immediately overlaying it. The function of the subbase and capping is to provide a platform on which to place the road base material, as well as to insulate the subgrade below it against the effects of inclement weather. The next thing, we have the road base. So in this road base, it is the main structural layer whose main function is to withstand the applied wheel stresses and strains incident on it and distribute them in such a manner that the material beneath it do not become overloaded. That is the road base. So and the last thing, basic components we have is the surfacing. So surfacing, as you can see in the presentation, the surfacing combines good riding quality with adequate skidding resistance. So while also minimizing the probability of water infiltrating the pavement with consequent surface cracks. So texture and durability are vital requirements of a good pavement surface, as are surface regularity and flexibility. That's all for that's under surfacing. That's what surfacing is. So those are the three basic components, which is, we recap it, the foundation, the road base, and the surfacing. So now in these highway pavements, there are two types of it. So we have here the flexible pavements and rigid pavements. So having a preview of these two types of pavements, starting with the flexible pavements. The flexible pavements is focusing the two basic components, which is the surfacing and road base materials, which are bound with bitumen bander, overlay granular unbound or cement bound materials. So that is what contains flexible pavements. So it will be broadened later on. After this, we have here the rigid pavements. So rigid pavements are quality concrete, so which is used for combined surfacing and road base, overlays granular cement bound material. So the concrete may be reinforced with steel. Kasi ginagawa niya siya kapag magsisemento ka, kailangan mo ng steel bars. So the general layout of these two pavement types is shown.
Hello po, ako nga pala si Hans Lirenz, one of the reporters po ako. At task ko po na i-discuss yung material in rigid pavements. So first, yung rigid pavement. So yung rigid pavements are constructed using a concrete slab over a subgrade or sub-base foundation. The pavement quality concrete PQC slab must be designed and constructed to withstand traffic loads and environmental stresses, ensuring durability and structural integrity. Proper material selection and construction techniques are critical for the performance and longevity of rigid pavements. Additionally, poor dowel bar placement can compromise load transfer efficiency at joints, leading to uneven settlement of faulting. This report discussed the material, slab design, joint details, reinforcement, construction methods, and curing process associated with rigid pavements. Okay, so first is the concrete strength. So pavement quality concrete typically has 28 days characteristic strength of 40 megapascal concrete, or we call it C40 concrete. So yung pavement quality concrete, meron siyang 28-day na characteristic strength na aabot sa 40 megapascal. Ito yung strength na kayang i-resist, no, ng concrete, o kayang i-resist na load sa concrete. So next is cement content, no. So a minimum of 320 kg meter cube of ordinary Portland cement OPC is required, no. Dito sa cement content naman, yung minimum na kailangan is 320 kg meter cube, no. Ito yung kailangan na minimum for cement content na gagamitin for cement mixture. Okay. Next is water cement ratio, no. A maximum ratio of 0.5 ensure durability and strength, no. Sa water cement ratio naman, ang maximum na kailangan is 0.5, no. Hindi pwedeng babawas sa 0.5 yung ratio ng water cement. Kasi pag bumaba pa siya sa 0.5, is possible na bababa yung durability and strength when it comes ng concrete when it comes in cement mixture. And next is air content, no. Up to 5% content is acceptable to improve workability and resistance to environment condition. So up to 5% lang yung content na acceptable sa para ma-improve yung workability ng isang concrete. Hindi siya pwedeng sumobra sa 5% kasi pag maraming air content sa isang concrete, bumababa yung compressive strength and durability nito. Possible na may high chance na magkakaroon ng cracks or structural failure. Okay, next, no, yung concrete slab and joint details. Rigid pavement slabs can be classified based on reinforcement and joint presence. So, first is the continuous reinforced concrete or CRC. Reinforced to handle induced stresses and prevent premature cracking. Yung continuous reinforced concrete, ang ginagawa nito is nire-resist niya yung tensile stress and pine-prevent niya yung crack caused by the traffic loads or temperature changes. And also, to have a long-term durability. Next is yung joint reinforced concrete. Reinforced with joints to accommodate movement and stress dissipation. No? So yung joint reinforced concrete naman is kinokontrol niya yung crack dulot ng shrinkage and ina-enhance niya rin yung durability ng pavement. Next is the unreinforced concrete o URC. Lacks of reinforced but uses joints to handle stresses. So first is the contraction joint. No? Yung contraction joint is kinokontrol niya yung shrinkage cracking and nire-reduce niya yung risk of uncontrollable crack and also in-improve niya rin yung durability and nire-reduce niya yung maintenance na kailangan. Next is expansion joint. No? Yung expansion joint is nagpro-provide siya ng control gap that allows the concrete to expand freely without causing damage. Kasi most of the material expand when heat and contract when cools down. Ang nangyayari dito, if nawala ng gap sa expansion ng concrete, ang nangyayari is nagkakaroon talaga ng uncontrollable cracks. Kaya napaka-importante yung expansion joint. At malaking tulong ito na para makontrol yung mga cracks sa concrete. Next, the reinforcement. So, material. So, prefabricated mesh. No? Yung prefabricated mesh, isa tong steel bars used to reinforce concrete. So, such as slab, pavement, and foundation. Yung prefabricated mesh ay kadalasan natin nakikita sa construction site. Ito yung parang steel bars na nag-form siya in grid form na ginagamit for foundation and also ginagamit for foundation sa structural buildings and roads. And also, next is the bar mats. Similar lang sila ng prefabricated mesh, typically feature larger and stronger shock. Next is the placement. No? The placement in reinforcement is crucial for its effectiveness. Kasi yung proper placement, ini-ensure niya na yung reinforcement is properly positioned and secured within the concrete slab. Lapping. So, yung lapping naman is ini-ensure niya yung structural integrity of the concrete and nag-provide siya ng continuous path for load transfer from another bar to next. Okay? Next is the cleanliness. Cleanliness also, ini-ensure niya yung durability ng concrete quality. And napaka-importante ito para maprotektahan sa corrosion or rust. Next is the pavement methods. First is the fixed form paving. No, ang advantage ng fixed form paving is it have a tight tolerance and side clearance. Inaalo niya yung precise control over the shape and dimension of the slab, resulting in tight tolerance and accurate side clearance. Second is the slip form paving, commonly na ginagamit for highways and interstate, airport, and parking lots. Next is curing. So, curing, first is spraying. So, ang ginagawa ng spraying is piniprevent yung moisture loss ng concrete and to have a proper hydration. Pag dehydrate kasi yung concrete, bumababa yung strength, yung durability niya, at madali siyang vulnerable sa mga cracks. No? Next is protective tents. Ang protective tents naman ay inaalo niya yung concrete to cure properly. Next is the skid resistant. So, micro-texture. Nagpro-provide siya ng drainage channels for water expulsion between tire and pavement at in-improve niya yung frictional resistance. Second is the micro-texture. It provides initial friction between tire and pavements in surface, and it helps to prevent tire from slipping on the surface. That's all in my report. Thank you.
Pavements deterioration. There are two kinds of pavements deterioration, the flexible pavements and the rigid pavements. In flexible pavements, heavy traffic roads often experience cracking or deformation of pavement surfaces, affecting the structural integrity of the highway. Proper maintenance of surface cracks and ruts can extend pavement's life. In flexible deterioration, there are four basic phases of structural deterioration. In phase 1, a new or strengthened pavement's load spreading ability continues to improve at its richest ability. In phase number 2, the load spreading ability is uniform, and the rate of structural deterioration can be accurately calculated. Phase number 3, the investigatory phase of pavement's deterioration is less predictable, requiring monitoring for remedial action. Residual life refers to the period before pavement reaches this phase. In phase number 4, pavement's failure necessitates total reconstruction for strengthening, a process lasting years with increasing maintenance until the cost make reconstruction the cheaper option. Rigid pavements, as stresses at slab edges promotes cracking in rigid concrete slabs, ranging from narrow hairline crack during drying a wide cracks 0.15 centimeter, causing water entry and partial loss of aggregates interlock.
Good morning everyone, this is me, Desiree Bernal, and today I was tasked to discuss the materials within a flexible pavement. But before starting, let's define what is flexible pavement. So, flexible pavement consists of a surface layer of bitumen band aggregate, such as asphalt concrete. These several layers of appropriate quality aggregate in the subgrade beneath. The layer enables the pavement to bend, reducing the damage and need for repair over time. So, flexible pavement consists of different layers. So, why? Why it is consists of different layer? Because by doing this, it will have a benefits such as reducing the damage over time for its life cycle or lifespan. So, that is the reason of flexible pavement. So, moving on, what is bitumen? So, bitumen is one of materials in flexible pavement. So, bitumen is produced artificially from a crude oil within a petroleum refining process. It is a basic constituent of the upper layer in the pavement construction. It can resist both deformation and changes temperature. Binding effect eliminates the loss of materials from the surface of the pavements and prevents water from penetrating structure. So there is two basic types of bitumen. This is the tar and the bitumen. So let's differentiate the tar and bitumen. First, the feature in terms of source. So tar is from coal woods or pit distillation, habang bitumen is from crude oil refining. So ang bitumen is from waste crude oil, so yung ni-refine na. So, the next feature is temperature resistance. So, si tar has a poor in heat resistance, then habang si bitumen has a stable across the temperature. So, flexible si bitumen compare kay tar. So, in terms of water resistance, si tar is highly water resistant siya, habang si bitumen is moderate. And speaking of durability, si tar has lower UV exposure, and bitumen has a UV exposure, has a higher UV exposure. So in terms of environmental impact, si tar has a higher toxicity and bitumen has lower toxicity. And in terms of usage, tar is limited while bitumen is widely used. So, in this topic, we are focusing on railroads. So, ito si tar, mostly ginagamit to siya pang waterproof sa mga bahay-bahay for structure. But ito si bitumen is ginagamit talaga to siya sa road.